Hey everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Matteo who has just completed the course ROS2 Basics in 5 days and he'll be giving us a presentation on that. So what I'm going to do is to hand over the platform to him so he can begin his presentation. Alright Matteo,
Hello, everyone.
whenever ready.
Okay, thank you.
Sure.
Hello, everyone. I'm Matteo, PhD researcher in University of Antwerp, and today I will present you my project for basic ROS with Python.
Mm-hmm.
Yeah, I would want to start with the real robot, but I need to wait 1 minute more, so we start from the simulation uh, to show you how my project works and then give you a brief description of the objectives and what we expect from this project.
Sure.
So the objective of this ROS2 project is to develop some nodes that will be able to control moving robot. And the objective of this moving robot is to start from a random position,
Mm-hmm.
find the closest wall, rotate towards this wall, then align on this wall on the right, and then start following the walls until it completes a length.
Mm.
So yeah, maybe it's already time to connect to the real robot. So maybe I will start from that one.
Mm-hmm.
Um, okay. So, nice. Okay. So put this one here. Put this one here. So we can see what the robot is doing. Where's the robot? I cannot see the robot at the moment.
Mm. Uh, did you say something? I think I'm losing your focus there, Matteo.
Oh, 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 sorry. I was looking for the robot in the images from the
I
real time,
Yeah, I think it's on
but
the
I cannot see him.
bottom right corner. So just click the reverse.
Ah, okay,
Yeah, so just
okay,
drag your joystick down.
okay.
It should reverse. Yeah. Yeah, there we go.
Oh, stuck somewhere. Oh, maybe it should move. Oh, okay, so I was hiding from him. I was scared from what I will do with him. Okay,
All
nice.
right.
So I will set up the directory and everything that is needed to make the ROS code works. So, okay, so I will use a launch script to launch all the nodes together.
Mm, okay.
We
Very
will
nice.
look in how they work.
Mm-hmm.
They will start all together, but the operations that the single nodes do
Mm-hmm.
are more or less in succession, so they are not done all together. At least
Mm.
the initial part. Um, so follower. Okay, fine. So now the robot is starting. As I was saying before, the robot is looking for the closest wall.
Mm-hmm.
It has inside a 360 laser from which we receive information,
Mm-hmm.
and then we can look for the laser with the closest distance, with the shortest distance.
Mm-hmm.
By knowing this information, the robot will start to rotate in that specific direction. So if the wall closest is the closest wall is on the right, the robot will start to rotate on the right. If it is on the left, on the left.
Mm-hmm.
And after that, as we've seen, the robot will move toward the wall to make it face on the front,
Yes.
and and then after we'll stop and start rotating on the left to make the wall align on the right.
Mm-hmm.
After that, the robot will start moving, following the wall, and it will try to avoid also going towards the wall when it has to make a turn. So we look before on the front laser to make sure that the wall it will start rotating on the left before going towards the wall, and then also we look at the right distance to make sure that it will stay more or less on a line following the wall. As we already seen, after the robot completes an entire lap, it checks for the position. It checks for the position every time it receives an information to be correct. And if the position of the robot is equal to the initial position of the robot with a 5 centimeter error, it will stop. And as we can see, the robot is stopped on the position in which it started.
Very nice, very nice.
Okay, so maybe I will move to the script so I can show you exactly on the nodes how this behavior is executed.
Yes, please.
Okay, as I was saying before, we have a launch script that we use with a simple command that I show here in the terminal. That is launch for the launch script. We'll execute altogether the 3 nodes that are the find node, the odometry recorder node, but also obviously the wall following node. So they will start all together, but as I said before, they will not be executed. Their main logic will not be executed immediately. We have a main. Yeah, sure.
Yeah, explain in more detail how you make sure that they don't start execution at once, or how do you set the order of execution?
Yeah. So we have a main node that is the wall following node. We can look at that now. I need to say that each node, maybe not each node, but even in the entire project, I used all the 3 main topics of not topics. It's not the correct
communication
word, but the main
mechanisms.
concepts. Yeah, exactly.
Okay,
Exactly.
right.
The communication mechanism of ROS that are the topics,
Yes.
services, and actions.
Yeah.
So each node is subscribed to a topic, and I will explain in detail to which topic and why.
Right.
But in the wall following, instead, we have also other 2 clients. The clients for the action server and the client for the service server. I will start from the service server because it's the first one that will be called, and it is connected to the wall finder. So as we can see here, we create a client for the find wall. That is in which here we declared instead the server. We create the service here, find wall, and at the beginning of this script, when we start the node, when the node it's launched, it will start from the main, obviously. And here we can see that we send a request. Send a request means that in this function, we ask to the server to do some action. How we stop the execution, because we want, the logic is we want to find the wall before, so make the robot rotate towards the closest wall, going closer to the wall, and then align on the right. But we don't want to do anything else when this action is done.
Okay.
We want to start the following actions after the wall is found, the robot is aligned to the right. So we want to stop the execution of the wall following script. How we do that? We wait with this command. We wait for the response of this service server.
Right.
So maybe I can follow the flow of the execution of the script. So we started with the wall following. The wall following calls for the service, and after after it calls the execution of the service, we go to the wall finder. So in the wall finder, we define a server for the service that is called, but we create, we subscribe to a topic that, as I was saying before, and
Mm.
topic to which we subscribe is the scan,
Mm-hmm.
one regarding the laser scan, because we want to receive the information of the distance. But we also create a publisher for another topic that is it's the topic for the velocity commands.
Right.
So the robot is subscribed to this topic by default. We receive this information, and with the velocity command, it will act. So if we say turn, it will turn. If we say going straight, it will go straight.
Mm-hmm. Mm-hmm.
So it's important that as soon as the service it's called from the wall following script,
Mm-hmm.
the execution will go on with a callback. So um, we have the callback for the service server. Here we just wait to be sure that at least one laser scan is registered, is saved in the local variable.
Mm-hmm.
So this is something that it's not done. It's done usually since they start all together. As soon as the wall finder is executed, it will subscribe to the laser topic. It will start to receive information from the laser topic. So we expect to already have some information here, but to be sure, we maybe wait until information are inside this variable, and then we can go on with the execution.
Mm-hmm.
Okay, so we receive the informations from the laser. We look for the laser with the smallest distance. We find its position. So by looking at the number of the laser, we know if it is on the right, on the left. We can locate the location of the laser by looking at the numbers and doing something with that.
Mm-hmm. Okay.
And then after we obtain we have some indexes for the lasers, and we are looking to make the shortest distance laser to be the index 0. Why the index 0? Because we already know that the front laser will have an index 0, so we want the robot to face the closest wall. So we want to rotate the robot until the laser with the shortest distance is the laser with index 0.
Mm-hmm.
And
Okay, so
so this
there's something very interesting here. So um it's very clear what you're doing. The question that I want to ask, and also for the sake of whoever's watching, is what happens when that shortest index is coming from an obstacle rather than a wall, right? So we want to understand how do you deal with that problem?
yeah, that's something that when I was writing this code, I didn't thought about,
Hmm.
because yeah, I thought about, but yeah, how can I deal with it? I didn't implement that to be to be
And
to be
did
sincere, to be honest. But
okay, yeah, it's understandable, right?
uh,
It depends if you encountered a failure, right? If you actually had an issue with that, right? So I want to ask you, did you have an issue with that, that you took it out, or you didn't focus on creating that guard?
I didn't found great issues. It happened one time because in the real world robot,
Hmm.
in the simulation robot, I didn't have any problem, because as soon as the robot starts, it will avoid the obstacle without any problem. The main problem is with the wall finder part. I was thinking about implementing something, um, yeah, by looking at not just the closest distance laser,
Hmm.
but also looking at many lasers altogether,
Okay, yeah,
and
that's good.
be sure that yeah, I should set a limit. So we want to avoid obstacles that are small because
Mm-hmm.
we are looking for a big wall.
Okay.
So an idea to be to implement this idea of small object if the object is small. So if the distance, yeah, because we expect that the lasers that are pointed towards uh, the wall, not just one laser. Yeah, we will have a laser that will have the smallest distance, but also the lasers that are close to this one will have distances that are smaller than the others. So maybe by not looking just at one laser, but looking at a bunch of them, we can decide if the object is that we are detecting is big enough to be thought as a wall. If
Okay.
not, we can skip that and looking for something else.
I
Yeah,
see. So you,
that was something that I was thinking about, but I didn't implement it.
yeah, I think you went the correct path, right? The only part that I want to make a follow-up on is, are you saying that you're looking for those indexes to be exactly the same, or you want them to be within a certain tolerance, right? So if you say, okay,
Yeah,
I'll get like the first 20 readings, or like 10 on either side of the my minimum, right? What are you looking at? Are you looking for them to be exactly the same, or?
no, I'm giving a tolerance for the lasers because
Right. Okay.
uh, in the simulation we expect to be everything under control. So we expect to have let's say instant communication.
Mm-hmm.
So if the robot is facing towards the wall, we will receive immediately the distance of these lasers. But
Mm-hmm.
maybe in the real world, since also we have a connection to a long distance, I do not expect to be that immediate. It could
Okay.
be we could have some delay that I should take into account. So I
Right.
inserted this tolerance to be to make the robot move even if it's not directly facing towards the wall. Yeah,
Ah,
the tolerance is rather small because we don't want to make the robot move in strange direction. We want to make it move towards the wall,
I
but
see.
even
Okay.
if it's not directly, like, yeah. So
Okay. So,
um,
what would be a follow-up to this is also, what behavior did you observe? Because I remember you said that you experienced this once, right, in the real environment, right, where your robot actually discovered an obstacle and assumed that it was a wall, right? Can you describe to
yeah,
us what was the behavior and how you recognized that is what was happening?
yeah. In maybe I can, yeah. We in the real robot we have this red wall.
Yes?
Uh, And if the robot happens to be closer to this wall rather than to any other wall,
Mm-hmm.
it will start to follow this wall. So it will do this same process. So it will start to rotate towards the wall. It will go through towards the wall, then it will align on the right, and then will start to follow this wall. So the behavior is, let's say, correct. So it will start
Yeah, yeah.
following the wall, but
Yeah.
not the correct one.
Right, right, right. Yeah, that's a good thing, right? It manages to exhibit that behavior on this one, right? I'm more interested about the smaller things, right? Like the signs that we normally find in the lab, for example, the ones that are on the left corners, right, both top and bottom. Did you have any issues with those, or you had uh,
It
you didn't?
happens sometimes. It happens sometimes that the signs were on the way of the robot when it
Right.
was moving already, following the wall.
Mm-hmm.
But yeah, I didn't experience any problem because the robot was able to continue following because they are rather small. So as soon as it will encounter them, if they were on the right, as we can see now, they are let's say really close to the wall.
Right.
So the behavior of the robot will remain unchanged because
Okay.
it will account for them as part of the wall. So it will continue following the same path. Yeah, let's say also the fact that the robot is moving and the objects are small, it will also not change that much the direction, the distance between the robot and the wall. So yeah, also as I will show you later on, I started with a bigger range, then I decrease it. A range for the robot. Let's say
The
it checks
threshold.
every time.
Okay.
Yeah, it checks every time how far is how far is it from the wall on the right to
Okay.
make corrections if needed. I started with a bigger range, but I noticed some problem in the real robot because it started to move in too much,
Oh,
rotating too much, and then I had problems with stopping the robot in the correct position. So I
right.
reduced it.
What range was that?
Um, Sorry.
What range was that that you were working with that gave you issues?
What? Sorry, I didn't get the
What's the
question.
range that you were working with
Ah,
that gave you issues? Yeah.
yeah. So the robots should stay at 30 centimeter of distance from the wall.
Right.
So I can quickly show you here. Yeah. So there are two distances to follow. 50 centimeter on the front. So as soon as the robot approaches to a turn,
Yes.
it has not to go farther than 50 centimeter towards the wall,
Uh-huh.
but it also has to stay at 30 centimeter of distance from the right.
Right, right.
So I was saying about, I was telling you about these two thresholds. So if the robot is farther than 31 centimeters, I want the
Mm.
robot to turn slightly on the right, so
Okay.
to realign on the right wall. But also if the robot gets too close, I want it to turn on the left a bit in order to make it follow a line, more or
Okay.
less. So
Okay, so you made your tolerance very tight. Okay. Yeah, interesting. Interesting, I see.
yeah, because I started and they were a lot, not a lot bigger, but they were bigger. But I have some issues with the real robot because it was not ending up in the same
Same
position because
position.
yeah, yeah, as I said before, there is some delay to account for.
Mm-hmm. Mm-hmm.
So maybe what I thought is that the robot is following its instructions, so turning on the right or on the left, but the nodes will receive too late the information of the distance, the actual distance. So maybe it turned too much on the right and is too close to the wall. So I decided to tighten them and also to decrease the movement to make sure that it will stay more or less on a line instead of moving too much on one direction, then have to correct too much after the direction and it starts wiggling on a line instead of following straight a line. And then after it's not a problem in the process of following the wall because it follows the wall actually,
Yes.
maybe not straight, but when it has to end in a specific position,
It becomes a
yeah, that could
problem.
be a problem.
Yeah. Yeah,
Yeah.
very nice. I like the way you implemented that, right? Because here's the thing, right? The easier way of doing this, right, without having to go through the amount of thought train that you went through, which is very good, by the way, is that most people would increase their tolerance, right? So they'll say instead of stopping within 5 centimeters, they'll make it stop within 10 centimeters. So, um, and I'm quite impressed by the way you did it, which you thought it from right from the onset to say, okay, I'm going to keep it on a very tight leash, and then I will hopefully get to the point that it started, and it worked, right? It worked right on the uh, first instance. So
Yeah.
that's really good, really good
Uh,
stuff.
yeah. So thank you. After going back to the wall finder behavior,
Mm,
we were talking about the rotation. So the rod rotates towards the wall, that is the closest wall,
mm,
and it stops if we are in the tolerance range that I declared before,
mm.
and we stop the robot. We need the robot to stop. After that, we start moving the robot towards the wall until we get a 30 centimeter distance from the laser with the index 0, so the front laser.
Mm-hmm.
We have a simple while loop here in which we check for the distance of the laser, and we check if it is actually close to the wall enough, and then we stop again the robot,
Mm-hmm.
and we go on with the next instruction, that is align the robot to the wall on the right.
Right,
So
right.
we're looking for a specific angle this time. We want to make the shortest distance to be the laser with the angle minus 90 degrees,
Mm-hmm.
because we with the angles we counterclockwise until 180 we have positive numbers, on the other side we have negative numbers, so we are
Right,
looking for minus 90 degrees.
right.
uh, and we do exactly the same thing as before when we try to find the when we try to move the robot with the to rotate the robot, sorry, until its shortest distance is the one that is facing towards the wall. But this time, instead of the laser that is front of the wall, we're looking for the 90-degree laser. So
Mm-hmm.
the operations are exactly the same, but with a different angle, uh, with a difference of objective angle.
Mm-hmm. All right,
Um,
Matteo. Unfortunately, we are out of time, but very, very
uh,
wonderful presentation. I loved it,
Thank
and I
you.
hope everyone watching could learn something new. One more time. Close your video and finish our conversation on Zoom. All right. All right, everyone. This was Mateo's presentation, and a warm congratulations to him. I'd like to encourage all those of you who want to try this course to also do the same, and you can also come and showcase your